everyone, and welcome to Activity 35. Today's notes are going to focus on the surface area of pyramids and cones. The notes are not from your book, but should be attached in Google Classroom. A reminder when we are looking at the triangle pieces, and if a side of a right triangle is missing, we can use our pal Pythagorean theorem in order to solve. So take a moment on your own to finish solving this problem to solve for the missing hypotenuse of this right triangle. Remember, we have A, B, and C is always the hypotenuse. So as we solve, plugging in A and B squared, we end up with x squared equaling 149. And in order to get x by itself, we are going to have to square root 149, which is about 12.2. Now, the reason we are going to talk about Pythagorean theorem a little bit again is because they're going to help us at times figure out a missing piece of our pyramids. Now, in order to find the slant height of a pyramid, you need a couple of different pieces. First of all, you will need the slant height of that pyramid. Okay, we call slant height this L piece. And then we also will need the perimeter of the base. So again, depending on the shape of your base, will help you figure out what the perimeter is. You will add up all four sides. In this case, because it is a rectangle or a square. Now from there, that would be our lateral area is the perimeter, 1/2 perimeter of the base times the slant height. There is also a height, and again, we know the height is from the vertex to the base, but that is going to be important to us when we talk about volume, not necessarily perimeter, or excuse me, area. So keep that in mind for that. Slant height is our important height of the day. So similar to finding the surface area of our prisms, again, you're going to focus on the base, what shape is the base, finding its perimeter and its area. If you're looking for total surface area, we have that one base. And again, you'll also need the slant height and ultimately plug it into the appropriate formula. So for this first one, we are looking for both the lateral area, which again is 1/2 perimeter of the base times the slant height, and total surface area, which is that lateral area plus the area of the base included. Remember, lateral area is just the triangular sides. So our base this time is a square, right? We see they have sides of 4 all the way around. So our perimeter of that base is going to be found by adding up all 4 sides that measure 4 centimeters each. So a total of 16. The slant height is also given to us in this particular problem. Our slant height is 8. So when we plug this into our formula, we have 1/2 the perimeter, which is 16, times our slant height, which is 8, for a total of 64 square centimeters. Total surface area then is going to involve us using that lateral area, but also adding in the area of the base. Well, again, our base is a square. So to get the area of that base, we're going to multiply length times width, or base times height, aka 4 times 4. So we would have a total of 16 as the area. 64 plus 16 is 80 square centimeters. Now from here, on the next page, we see a note of warning to be careful that it is the height that is given of this pyramid, not the slant height. So this is where the bell ringer comes into play, because in order to get the slant height, we need to use our pal Pythagorean theorem. Now, something to be careful of is our base. This time we have a square base, which each side equals 6, which means that this piece here is going to be half of that value, so 3. So in order to find our hypotenuse, it's going to turn into what we needed to do for the bell ringer using a squared plus b squared equals c squared, where our 2 legs are half the side length and then that height. So we end up with our slant height squared is going to equal 25 plus 9, which is 34. And then square root both sides to get our final answer of 5.8 as our slant height value. So if we want the lateral area and the total surface area of this particular problem, remember lateral area is 1/2 perimeter of the base times the slant height. Perimeter of the base this time, you have to add up the 6's 4 times, total of 24. And then we have that slant height of 5.8. So our total value there is going to be 69.6. Total surface area then is going to involve us adding in then the area of the base as well. So our base again is a square. So the area of a square is 6 times 6 this time, which is 36. And our total surface area is going to be the lateral area plus the one base. So 69.6 plus that area of the base is going to give us a total of 105.6. So from here, now we have the lateral area and the surface area of the pyramid. We also want to be able to talk about combining some shapes. Now notice here, if we have this pyramid on top of a prism, we only need the lateral area of the pyramid, and we only need to include one base of the prism because you only want to think about the areas you can touch. We are not touching the base of the pyramid / the top base of our prism. So reminder, lateral area of a pyramid is 1/2 perimeter times the slant height. And lucky for us, this is actually going to have the same perimeter as the problem up above, since the sides are all 6 still. So our perimeter of this one is 24. Slant height this time is 5. So 1/2 of 24 times 5 is 60. And then again, surface area of our prism, it's going to only be the lateral area plus one base because again, we only have one base exposed. So lateral area is perimeter of the base times the height plus that one base. Now our bases again are the same size here. So perimeter of the base is again going to just be adding up 6 4 times. So a total of 24. Height of our prism is 6. And then again, the area of the base this time is 6 times 6, or 36. So our total here then is going to be 180. Finally, to get that total area of our figure, we're going to have to add 60 plus 180 together for a total of 240 square centimeters. All right, now this next piece then, we are going to look at then talking about the cones surface area as well. So cones, again, are dealing with a slant height when we talk about their lateral area or total surface area. The actual height is going to be reserved for the value. And our lateral area is found by taking pi times the radius times the slant height. Total surface area, add on that one circular basis area to it, so pi r squared. So as we look at our first example, they're asking us for the lateral area and total surface area of the given cone. And again, our cone this time has a radius of 5 and a slant height given of 21. So lateral area is pi times r times l, our slant height, pi times 12 times 21, making sure we use the pi button. Pi times r, which is 12 times 21, we get about 791.7. Now the total surface area then, we're going to take that 791.7 and add to it pi times that radius value squared. And again, you could type all this into the calculator. We have 791.7 plus pi times 12 squared for a total of 1,244.1. And again, if you're into writing down the units, it's always units squared for area. Now, sometimes when it comes to problems with cones, you want to think about situationally. Sometimes, for instance, with a party hat, you only need the lateral area because we don't have a base showing. But sometimes you will need the base. For instance, if we are looking for the surface area of our ice cream cone container, including the lid. So that's what this last piece is. If I'm selling these frozen fruit bars with the cone-shaped wrapper that includes the lid, we are going to actually be looking for the total surface area of our cone, which is pi times the radius times the slant height plus pi times the radius squared, the one base. So looking at our given information, they're giving us the diameter is 6, which means our radius is half of that, so 3. And we have to be careful because they gave us the height, but we need, in order to solve this problem, the slant height. So again, Pythagorean theorem is your front. Slant height is going to equal 13 squared plus, again, half of the diameter is 3 squared. So we have 13 squared plus 3 squared, which is 178. And the square root of this is going to give us a slant height of 13.3. Now that we have the radius and the slant height, we can finally plug in to get our final answer. Pi times our radius times our slant height plus pi times our radius squared will give us our final answer. And again, we could type all this in at once. So pi times the radius times the slant height plus pi times our radius squared gives us a total of 153.6. So that's how much paper we're going to need in order to create our cone. Thanks everyone for watching. Definitely we'll work more with our surface area and lateral area in class.